So welcome to our lesson again. We have been dealing with the matrices, and we laid the foundation in our previous lesson. We discussed the notes. So today I want us to have some questions, some general questions, and I want us to go to this paper of December 2024. December 2024, question number 1C. Question number 1C, that's where I want us to begin. Go to your past papers there. So the question reads that the 2 by 2 matrices A and B are given below. So we are given that. So given that AX is equals to B, find the values of A, B, C, D. So they are telling us that matrix AX is equals to B. What that means is we have this matrix A, which is 10, 4, 4, 2. 10, 4, 4, 2, that is the matrix. It is multiplied by this matrix, A, B, C, D. A, B, C, D. And when we multiply, we have gotten 18, 14, then 8, and 10. That's what we have gotten. So if that is what you have gotten, now they're asking us to tell them what is the value of A, B, C, D. So in this case, we said when you are multiplying matrices, you take this row, multiply by this. So it's going to be 10A plus 4C should be equal to 18. Should be equal to 18. Then I take this 10 multiplied by this. So maybe this one I can call it equation 1. Then I take 10 times B. So 10B plus 4D. 4D should give me this 14. So that one I call it equation 2. When I multiply this by this. Then I need to multiply this row by this column so that I have 4A plus 2C is equals to 8. So that one I call it equation number 3. Equation number 3. Then this one by this. So 4b plus 2d is equals to 10. So this is equation number 4. Equation number 4. So we now solve. So solving 1 and 3. I want to solve equation 1 and 3 because hizo ndio zinafanana in terms of the. So I will talk of 10a plus 4c is 18. Then 4a plus plus 2c is equal to 8. We can solve using elimination method, but because you're in the topic of matrices, I want to use matrix algebra because we looked at how to solve equations using matrices. So using matrix method to solve, these simultaneous equations. These are simultaneous equations. Tulisema unachukua hizi coefficients. So 10, 4, 4, 2. That way. Times unachukua these algebras. That is A here and C. These two that are knowns. Unaziweka hapo. Then you have the result matrix 18 and 8. 18 and 8. Unaziweka hivyo. So when you do that, tukasema hii inaachwa on its own side, A and C that way. Then hii inaingia the other side, 10, 4, 4, 2. Inaingia ikiwa inverse. Inaingia ikiwa raised power minus 1. Inverse hivyo. Because imebadilisha position. So to come and multiply 18 and 8. Now we said when you are given or you are looking for the inverse of a 2 by 2, this is an inverse. The first thing is to get the determinant. So the determinant, tukasema you take the major diagonal elements, 10 times 2, you subtract the minor diagonal. This and this multiplied 4 times 4. So if you go to your calculator and say 10 times 2 minus 4 times 4, you get 4 as the determinant. Then you get the new matrix. Now new matrix tulisema you change the positions of the major diagonal here. So this is 10. Sorry, we are changing the positions. So when you change, 2 comes here and 10 goes here. When you change, then you change these signs. So this becomes -4 and this becomes -4. That way, that's what we call new matrix. So with this one, we have the values required to get the inverse. So we come back here and say A, C should be equal to, so the inverse, tukasema ni 1 out of the determinant, so 1 out of 4 multiplied by the new matrix. The new matrix is 2 minus 4, then -4, 10. Multiplied now that by the result matrix here, 18, 8, 18 and 8. So when you proceed, you say A, C. 1 out of 4. Tulisema to multiply matrices where this row na multiply hii column. So this will be 2 times -18 plus -4 times 8. This one multiplied by this. Then we take this one. -4 times 18 plus 10 times 8. So when you come down here, this will be 1 out of 4. You now solve this one. Useme 2 times -18. Now, where have I gotten -18 from? It's not -18, it's just 18. 2 times 18. Yes, 2 times 18, not -18. So 2 times 18, 2 times 18 plus -4 times 8 is equals to 4. Then hii ingine -4 times 18 plus 10 times 8. I'm getting 8. So now, when you open the brackets, this is a scalar matrix. This one you multiply by quarter, this becomes 1, and this one becomes 2. That becomes 2. So thus A is equal to 1 and C is equal to 2. Yeah, so that is how we can solve this. So we need now to proceed and solve the other one. Haya, so tunaendelea hapo chini sasa, tunasema solving equations 2 and 4. 2 and 4. So this is 10b plus 4d is equals to 14. Then 4b plus 2d is equals to 10. So those are the two equations. Higher. Then using matrix algebra, to solve the matrices, you take these coefficients. So this is 10, this is 4, this is 4, this is 2. Times, this is B, this is D. Should be equal to 14 and 10. That way. So when you do that, tasema, this one comes here, BD on this side. Then you take this one, 10, 4, 4, 2. Na inaingia hapo ikiwa inverse raised to power minus 1. Minus 1. So times 14, 10. So sasa, to get the inverse, tukasema you get the determinant first, which is 10 times 2 minus 4 times 4. This is what we had in the other one. So this is 20, this is 16. So that gives us 4. Then you get the new matrix. New matrix, tumesema, you change the positions. So this is 2, this is 10. Then here, you change the signs. So this is minus 4, this is minus 4. That way. So with that, you proceed here and say B, D. 1 out of the determinant. You have the new matrix, which is 2 minus 4, then minus 4, 10, multiplied by this one, which was 14, and 10. 14 and 10. So with that, we proceed and say this is B, this is D. Is equals to 1 out of 4. So you multiply this row times this. So we are going to have 2 times 14 plus minus 4 times 10. Then this is minus 4 times 14 plus 10 times 10. That way. So this proceeds on to become BD here. Is 1 out of 4. So ukisema 2 times 14 plus minus 4 times 10. That's giving us minus 12. Then minus 4 times 14 plus 10 times 10 is 44. So when you multiply by a quarter, this comes to minus 3 and this comes to 11. That comes to 11. So thus, B is minus 3, B is 11. Hence, this matrix X was AB. AB we had gotten, I think A ndio tulikuwa tumepata 1, B ni minus 3, C tukapata 2. Yeah, so that is the matrix that you are told to look for. That's the matrix that you are told to look for. So on the same paper, you shall attempt question, so this paper of December 2024, question 6A. Question 6A, you shall look at what is asking. Okay, so with that, I want us to go to April 2023. Question of April 2023. Question number
10 to 2. Yeah? Later change. Later change.
5B.
As in after 30 minutes, 30 minutes, 30 minutes, 30 minutes. 30 minutes.
So, a trader purchased 7 cartons of apples and 4 cartons of bananas at a total cost of that 2,500 in the month of January. So in the month of February, he purchased 9 cartons of apples and 6 cartons of bananas at a total cost of 43,500. Required. Calculate the cost of a carton of apples and a carton of bananas using matrix algebra. So in order to solve that, if you remember what we said in our notes, we will say let we have apples and bananas. So let A to be the cost per carton of apples, per carton of apples, and B to be the cost per carton of bananas. Yes. Then equations. You create equations. You create equations. So creating equations, we are told a trader purchased 7 cartons of apples and 4 of bananas. So 7A plus 4B. And when he did so, he paid an amount of that 2,500. That 2,500. That is in the month of January. In February, he purchased 9 cartons of apples. So 9A plus 6 of bananas. So 6B. At a total cost of 43,500. So that is how you create the equations. That is how you create the equations. Then you create the matrices. You create the matrices. So the matrices will be 7, 4, 9, 6. I told you you pick these coefficients. Then you take these unknowns, the algebras, A, B, to be equal to that 2,500, 43,500. Then from there, we start solving so that you have A here and you have B equals This one is 7, 9, 4, 6, and it comes in as an inverse. Comes in as an inverse to multiply that 2 500, 43 500. So tukasema ukifika hapo, you now look for the determinant. It will be 7 times 6. That's the major diagonal. Minus 9 times 4, the minor diagonal. So you take your calc, same 7 times 6 minus 9 times 4. That is 6. That is 6. Then you create new matrix. New matrix is 6 here and 7. Then this is minus 9 and this is minus 4. You change the signs. Now that they were positive, you make them negative. If they were negative, you'd have made them positive. Higher. From there, you now proceed on and say A, B should be equal to 1 out of 6. This is 6, this is minus 9. This is minus 4, this is 7. Times that 2 500. 43 500. So proceeding on, you get AB. 1 out of 6. So you now take 6 times that 2 500 plus minus 4 times 43 500. Then minus 9 times that 2 500 plus 7 times 43 500. So this proceeds on to become we multiply this one. Same as 6 times that 2 500 plus minus 4 times 43 500. It's 21,000. We have 21,000. Then minus 9 times that 2 500 plus 7 times 43 500. It's 12,000. So this is when you open the brackets, You divide, this goes to 3,500 and this is 2,000. So hence or thus, A is 3,500 and B is 2,000. Yeah, so that is how it's solved. Yeah, so I think we have solved the equations now that way. So now you should be able to understand that when you combine with the one we had in the illustration, the notes, you should now be able to handle or to solve any simultaneous equations. The next one that I want us to solve is August 2022. August 2022, question 1A. Question 1A. So if you are there, the question says that Saudi company has received an order to supply 900 tables, 1,200 desks, and 200 chairs. The management of Saudex company has decided that 500 tables, 800 desks, and 1,300 chairs could be supplied from their city center branch, and the balance of the order could be filled from their industrial area branch. Now, production of each table requires 3 hours in the machining department, 5 hours in the assembly department, 4 hours in the finishing department. Production of a desk requires 4 hours in the machining department, 8 hours in the assembly department, and 6 hours in the finishing department. Production of a chair requires 2 hours in machining department, 3 hours in the assembly department, and 5 hours in the finishing department. The cost of an hour in the machining, assembly, and finishing department is that. Now, using matrix algebra, calculate the total number of hours required at each branch. The number of hours required at each branch. So if you're told to get the hours required at each branch, now the first thing is to get the matrices. Let's work this way. The matrices. So the first one is the order matrix. So the order matrix, the total order matrix, they have received an order to supply 900 tables. So we have the tables, we have desks, and we have chairs. So they have been given the order to do 900 tables, 1,200 desks, and 2,000 chairs. So this one is a 3x1 matrix. It has 3 rows and 1 column. The other matrix, wanasema, the management has decided that 500 could be supplied from there. So we can have what I would call production matrix. Production matrix. So this production matrix, we have the item here, tables, we have desks, and we have chairs. And this production is taking place in 2 branches. There is a city center and the industrial area. So let me just use the word city and the word industrial. Branches, that way. So they are saying they have decided that 500 tables, so these tables, 500 from the city. So that means industrial, from these 9, industrial will do 400. Then desks, city will do 800. From these 12, that means industrial will do 400. And then the chairs, city will do 1,300. So from these 2,000, that means industrial area will do 700. Yeah, the balance of the order could be filled from the industrial branch. Now, production of each table requires 3 hours. So the hours. So we need to create a matrix of hours per unit matrix. And I needed to have said this is a 3x2. This matrix is a 3x2. So for the hours, we have a table. We have table. We have the desk. And we have the chair.
Sina fruits.
Utachukua wapi?
Naweza chukua kwa mburu.
Chukua ile hapa.
Okay.
So for the hours is we have 2 departments. There is machining. There is machining here. We are told production of a table requires 3 hours in machining. So table machining 3. 5 hours in assembly. Oh, we have another department inaitwa assembly. 5 hours. And 4 hours in finishing. So we have another department inaitwa finishing. 4 hours. That way, production of a desk requires 4 hours in machining. We require 8 hours in the assembly. And 6 hours in finishing. Production of a chair requires 2 hours in machining, 3 hours in the assembly, and 5 hours in finishing. Yeah, so those are now this one is a matrix of 3 by 3.
Like what?
3 by 3. The next matrix you can create from there is the cost of an hour. So hourly cost matrix. Hourly cost matrix. So the hourly cost matrix, we have machining, we have assembly, we have finishing. So we are told this is 50, this is 100, and this is 150. Now this is a 3 by 1. So let's see how now we will respond to the question. Calculate the total number of hours required at each branch. So we will need to get these tables that will be made multiplied by these hours. So total hours matrix. So total hours matrix. So total hours matrix. Now, if I start to multiply, to remember when you are multiplying, you must ensure that the columns in the first matrix are equal to the columns to the rows in the second matrix. So that when I take this and I multiply, so this cannot be the first matrix, but this can be the first matrix because you can see the columns here are equal to the rows here. So I will have to start with the one for the hours. I will have to start with the one for the hours. This one. I will have to start with the one for the hours. So this will be the hours times the production to give us the total. So this one, this is 3, 4, 2, 5, 8, 3, 4, 6, 5. Then I multiply by the production, which is 500, 800. So let me see. This will multiply This is for the table. Five will multiply, so that will not work that way. That will not work that way because it will be this way. So this 5, when it comes to multiply this, these are desks. So that cannot work that way. So we have to ensure that they are compact, they are feasible. That the tables will multiply the hours for the tables. That is what we call the economic sense. So lazima tuhakikishe that they agree. So I can transpose this. I can transpose this so that I have so if I transpose this, then I will have to start with the production times the hours. That will be the total. When I transpose, this will be the set here. This will be industrial. These are tables. These are desks. And these are chairs. So for the city, we have 500, we have 800, and we have 1300. Industrial 400, 400, and 700. When I transpose, so that now it becomes a 2 by 3. Now that 2 by 3, I will multiply by this one, the way it is, this one. So that this is 3, 4, 2. Let's check whether that now agrees. These are tables. I multiply by 3. It is the time for making a table. These are desks. I multiply by 4. It is the time for making a desk. These are chairs. I multiply by 2. It is the time of making a chair. So sasa iko sawa. So this is 5, 8, 3, 4, 6, 5. So I now multiply. And when I come to multiply, the matrix I'll get to tulisema, it will have rows. It will have rows of the first matrix and the columns of the second matrix. So this will be city and this will be industrial. Those are the rows of the first matrix. Hii ndio inaitwa second matrix. So the second matrix, the columns are machining, then we have assembly, and then we have finishing. That way. So we start to multiply. So we shall just multiply as you have been saying. So unachukua hizi, una multiply hivi. You get the answer here. So I'll say 500 times 3 plus 800 times 4 plus 1300 times 2. This gives us 7,300. Then I take 500 times 5 plus 800 times 8 plus 1300 times 3. 12,800. Then I take 500 times 4 plus 800 times 6 plus 1300 times 5. 13,300. 13,300. Then you take this, you do the same now. We repeat. So 400 times 3 plus 400 times 4 plus 700 times 2. This is 4,200. Then you take this, multiply by the second column. 400 times 5 plus 400 times 8 plus 700 times 3. 7,300. So 400 times 4 plus 400 times 6 plus 700 times 5. 7,500. Yeah, 7,500. So those are the hours. Finally, we are told to get the total cost incurred at each branch. The total costs incurred at each branch. So if these are the hours, we multiply by the hourly cost. Now this is a 2 by 3 matrix. 2 by 3. So to ensure that they are compatible, we will start with this one so that we have these 3 and these 3. So this one becomes the second matrix. So the total costs when you are asked to get the total costs, we shall get the total hours. The total hours times the hourly costs. The hourly costs. So hii itakuwa 7,300, 4,200. Haya, 12,800, 7,300. 13,300. 7,500. We now multiply by this one. 50, 100, and 150. And 150. So when we multiply, I can rub this one now. When we seek to multiply, this will become the first matrix. This was the city, and this was industrial. So tutamultiply hivi na hivi. So tuanze tuseme 7,300 times 50 plus 12,800 times 100 plus 13,300 times 150. That is 3640. 3,640,000. Then 4,200 times 50 plus 7,300 times 100 plus 7,500 times 150. 2065. So that is the cost that is incurred in each branch. So the total cost, should then be this 3,640,000 plus 2065 plus 2065, so that is 640. 570. Yeah. So that is the total cost. So that is how we go about it. Looking for another question I'm not able to find. Okay, so maybe as you peruse your past papers, you come across. I was trying to look at for a question. So that's basically how to deal with the matrices, the general cases. Thank you.